Hey guys, I want to let this focus and we can get started. Okay, today, even though your packet says Tuesday, it is Wednesday's work since we had Labor Day. And when I was planning this, totally forgot about Labor Day. So, this is Wednesday's math video notes. Okay, so today what we're going to do is we're going to compare, we're still going to compare decimals, but we're going to throw something into it. We're going to throw the whole number into it. And to be honest, it doesn't make a bit of difference when we compare. It's just adding another number. So let's look at it. Gary and Melissa compare the distances they walk each morning to get to school. Gary walks 3 and 275 thousandths kilometers. Melissa walks 3 and 24 hundredths kilometers. Who walks the furthest to get to school? Now, remember, then they're going to model this for us just to show it. You can do this a few ways. You can express the two numbers as a fraction, but to do that, you have to have common denominators. So Gary, who walked 3 and 275 thousandths, would simply be 3 and in the fraction 275 over 1,000. Melissa is 3 and 24 hundredths, so you'd have the whole number 3 and the fraction of 24 over 100. But we have to have common denominators, and the 100 and 1,000 are not common. So you just ask yourself, what did I have to do to 100 to get to 1,000? I had to multiply by 10. So just like down here, you multiply the top and bottom by 10. So now I'm comparing 3 and 275 thousandths to 240 thousandths. Okay, another way, and this is the way I prefer because there's not as many options to make mistakes, you just model it. You write the distances in a place value chart. And then you start at the largest unit and you start to compare. In the ones place, they're both 3s. In the tens place, they're both 2s. In the hundredths place, that's where we get our differences. We have a 7 and a 4. And if we were just comparing the two numbers 7 and 4, the 7 is larger than 4. So that means that this number right here is larger than that number. So you could just come right back down here, and they wrote it out like this, but I would have you do 3 and 275 thousandths is greater than 3 and 240 thousandths. Or you could have just left it like the number was on the paper, and it means the same thing. Okay. So the next one. Okay. Both model it, change the way the fractional part or decimal part of 3 and 24 hundredths is represented. Right here. That's what they mean. Right up there. Sorry you can't see that. That's what they mean. What is the same about how the denominators of the fraction and the place value of the decimal change? What is the same? What did we do to go from 3.24 to 3.240? And then what did we do to go from here to here? See it? Yes, we increased the number by a power of 10. We increased the number by a power of 10. What is the same about how the numerator of the fraction and the digits to the right of the decimal point change? Well, it's the same thing. We increased the number by a power of 10, which meant we just added a 0 to the end of the number. That's all we had to do. The only thing that changed, the same thing that changed is that, like we just said before, we increased it by a power of 10, which meant we added a 0 to the 24. So basically, we'll have to put that in a way that's understandable. What is the same about how the numerator? Okay. Let's see. Both numbers increased by a power of 10, meaning we added a 0 to the end of, oops, sorry, left out end of each number. All right. How does rewriting the fractional part or the decimal part of 3 and 2400s make it easier to compare? That one and that one. Well, the fractional part would be they have the same denominator, and the decimal part is that the numbers have the same number of digits, which makes it easier to compare. So I guess we could just put both numbers have the same number of digits. Now, when I say digits, I'm referring to like when we compared the 3 and 275 and then 324. We put that 0 there, and there's the same number of digits. Explain how you can use what you know about comparing 240 and 275 to help you compare 240 over 1,000 with 270 over 1,000. Well, since we know that 240 is less than 275, since we know that in a whole number, it would be the same as a fraction portion. So let's see. If 275 is greater than 240 as a whole number, then it would hold true as a fraction / decimal. I'm sorry if y'all hear crunching and other stuff. My dogs are out right now. Okay, let's try it. Use what we know to compare the decimals and solve the problems to show your work on a substitute paper. We're just going to show it over here on the side. Okay, it says Heather's rabbit has a mass of 5 and 190,000 kilograms. Jeff's rabbit has a mass of 5 and 195,000 kilograms. Write an inequality statement comparing the two masses. Remember, inequality, greater than, less than, equal to. So over here on the side, I'm going to go 5 and 190 thousandths, and then 5 and 195 thousandths. Okay, so now what we got to do is just compare the digits in the place values. Our ones place are the same with 5s. Our tenths are the same with the 1s. Our hundredths place are the same with the nines. So the digits that are different are coming to the thousands place. Okay, I have a 0 and a 5. Which one's larger? That's right, the 5. So I'm going to rewrite this inequality, and since this number is already first, I'm going to rewrite it as first. So 5 and 190 thousandths is less than 5 and 195 thousandths. Okay, less than. Okay, Braden and his cousin Kayla live 25 miles away from each other. On the same day, Braden recorded 1 and 46 thousandths inches of rain at his house. Kayla recorded 1 and 62 thousandths inches of rain at her house. Whose house received fewer inches of rain? So they're trying to throw you off, but they want to know who received fewer. So we don't have to write an inequality statement. We just have to answer the question, whose house received fewer inches of rain? Okay, so Braden had 1 and 46 thousandths. Kayla had 1 and 62 thousandths. Okay, just like we normally do, we're going to start in our greatest value with our 1. Okay, there's your 1s are the same, the 0s are the same, and this is where we have our difference. So which one's larger? Okay, this is the larger number, but it's asking us the fewer inches. So we got to go, our answer is going to be the lower number, which is Braden. And I'm just going to go right here and go just like that. All right, now, this right here is your last piece of work for the day. And I'm going to strongly suggest that you get a clean sheet of notebook paper, or not actually necessarily clean because I'm not using a clean sheet, but a sheet of notebook paper to help you out. Because I don't think many of you could write it up here neatly and show me what you got. All right, so we're going to go least to greatest. So that means your smaller number to your biggest number. Okay. So we have 3 sets of numbers on each problem, and you have to write the numbers in the boxes in the order they go in. Okay, so the first thing you're going to do, or that I would do, is I'm going to look at the first problem. I'm going to come over here to my sheet of paper, and I'm just going to go, this is just how my mind works. I'm going to go number 1, and I'm going to write out 9.7, 8.79, and then 9.78. Okay, first thing I'm going to do is I want to make sure that the numbers have the same number of digits. So I'm going to go ahead and add a 0 to my top one to make it 9 and 70 hundredths. Okay, so we're looking for least to greatest. So before I even go down here to write it, I usually do something like this. Okay, I'm going to start off with my greatest place value, which is my ones place. Okay, I have a 9, an 8, and a 9. Okay, we have different numbers. Which one's the smallest? Okay, the 8. Okay, now that automatically makes it their smallest number. So I'm just going to put a 1 right here. Okay, so now we're going to go from 9 and 9 to the tens place. Okay, and honestly, I'm going to go ahead and just do this right here because some of the kids may continue to do that. I have a 7 and a 7. Those are the same. So I'm going to move my next number. A 0 and an 8. 0 is smaller than 8, so this is my number 2, and this is my number 3. So that's all you have to do. So I'm going to come right down here and write the smallest, the next number, and then the next number. That's all you got to do. All right, let's look at the next one. I have 3 1 and 317 thousandths, 1 and 137 thousandths, 1 and 37 hundredths, which I'm going to change to 37 thousandths. All right, now we just compare. Our ones are the same. Okay, so that means I'm going to move over to my tens place. I have a 3, a 1, and a 3. Your 1 is the smallest, so it is going to be done first. Okay. Now, I have a 1 and a 7. The 1 is smaller than the 7, so it's going to go like that. Okay, so just come right over here and write your numbers down. Oops, wait. No, got it. Yeah, okay. No, I wrote the same number twice. What did I do? No, I didn't. Sorry. I do not like it when they put these numbers like this close together. I hate it. Okay. Last one we're going to do is a group, and then I want you to do the other 3 by yourself, and I will check it when you turn in your packets next week. Okay? So we're going to do 6 and 72 hundredths, 7 and 6 tenths, then 6 and 27 hundredths. So we're going to come over here to my paper, write the numbers down. I'm going to space them out just a little bit better. Okay. So I'm going to go ahead and compare. I have a 6, a 7, and a 6. The 7 is my larger number. So I'm going to go ahead and do this one as my big number. That's my third number. Okay. So I have a next 7 and a 2. I know the 2 is smaller than the 7, so 1 and 2. Okay. So I'm going to write my numbers out. 6.27, 6.72, 7.6. All right, so I want you to continue doing this. I want you to compare these 3 sets of numbers, and I will check it when you turn in your packet next week. Now, just remember, just line up your numbers. Do not worry about having to do the fractional thing. Just work with this, line them up, and then compare the numbers in each place value. I will talk to y'all later. Have a good day.